Okay, next one we look at question B. Determine the total distance traveled by the leaf and its displacement. So we want to find total distance and also total displacement. Okay, so remember to find the distance and displacement, you have to calculate the area under the graph. So you need to calculate the area under the graph to find distance and displacement. So the only difference here is for total distance, you just ignore all of the negative value. But for displacement, you need to include the negative value. So this one include negative. This one just ignore the negative. Okay, so how to calculate the area under the graph? So we just need to divide them into parts. So first of all, we have this first part here. Okay, let me label as A1. And then second, we have, so the first part here is triangle. So we can find the area using the formula for the triangle. And then second part here, we have the area. Okay, kalau kamu tengok dekat sini, this shape is actually a shape for trapezium. So we can find using the formula for trapezium. And then the next one is also the shape for trapezium. So using the trapezium as well. And then this one here is the triangle. And then last one here is the trapezium as well. So A5. So we need to find 5 area. Okay, so kita buat one by one. So A1, okay, using the formula for, okay, let me write down the formula first. Okay, formula for the area. Okay, half times width, the height and the base. And also for trapezium, it's 1/2 times width A plus B times width the height. Okay, so now kita tengok A1. A1 adalah, A1 is triangle. A1 is triangle. Okay, A1 is equal to 1/2 times the height. So the height here is 2 and the base is 5. 1/2 times the height, 2 times 5, so you will get 5. And then A2 is the trapezium. So the base here, the height here is 10. Okay, 15 minus 5, so 10. And then you need to plus these two sides, which is 2 plus 4. 1/2 times with 10 times with 2 plus 4, which is equal to 30. And then A3 is another trapezium. So the height here is 4, and then these two sides, 10 plus 4. Is it 4? Sorry, 10 plus 5. Ini 10, ini 4. So height adalah, okay, I'm sorry. So this one is 10, this one is 5, and the height is 4. 1/2 times with 4, and then times with 10 plus 5, which is equal to 30. And then A5, okay, bukan A5, A4. A4, which is here, is another triangle. So 5 times 4. 5 times 4 is equal to 10. And then last one, A5, is another trapezium. So these two side is 5 times 5 plus berapa ni? 15. And then times with 4. 1/2 times 15 plus 5 times with 4, and then you will get 40. So this one, kalau untuk distance, total distance, you just add everything. A1 plus A2 plus A3 plus A4 plus A5, which is 5 times 30 plus 30 plus 10 plus 40, and then you will get total distance is equal to 115 meter. Okay, this one adalah untuk distance because we ignore the negative value. And then next one, displacement. Total displacement. Okay, total displacement, you need to include the negative value. So dekat mana yang ada negative value? Dekat dua ni, A4 and A5. A4 dan A5, okay, akan ada negative value. Dekat negative dia adalah negative 4 dekat sini. So dalam pengiraan kamu kena letak negative 4 ni. Okay, you don't have to calculate again. You can just letak dekat bawah. Dua ni 1/2 times 15 plus 5 times with negative 4. So you get negative 4. And then this one pun 1/2 times 5 times with negative 4. You get negative 10. So just tambah sahaja. 5 times 30 plus 30, 5 plus 30 plus 30 minus 10 minus 40, and then equal to 15 meter. Okay, so this is the displacement, and then this is the distance. Okay, boleh? Okay, we have another 2 questions. Okay, 3 questions actually. Okay. For C, calculate the average acceleration between 20 seconds to 40 seconds. Okay, so we need to find the acceleration between 20 seconds to 40 seconds, which is, where is it? 20 seconds to 40 seconds. Okay, daripada 20 ni ke 20 saat ke 40 saat. So how to find this one? Okay, soalan C, we want to find average acceleration kan? So formula untuk average acceleration adalah, okay, velocity 2 minus velocity 1 divided by T2 minus T1, which is actually you can just tengoklah first velocity 2 tu dekat mana, which is dekat sini, dekat point 40 second ni velocity dia adalah negative 4, dan dekat point 20 second ni velocity dia adalah 4. Okay, 40, negative 4 minus 4 divided by 40 minus 20. So you will get negative 0.4 meter per second squared. Okay, so average ni adalah formula daripada nota kamu saja, and then V2 minus V1 ataupun V final minus V1, V initial, sebab dia adalah in between these two time interval kan, this. Okay, daripada sini ke sini, so final dia adalah dekat sini, which is negative 4. Initial dia adalah dekat sini, which is 4. Okay, so that one is easy. Okay, next one, we need to calculate the average speed and average velocity from the graph. Okay, average speed, you want to find average speed and then average velocity. Okay, so kalau menggunakan graph, Okay, average speed actually, okay, average speed is actually the total distance, okay, total distance divided by the total time. And average velocity pula is the total displacement divided by total time. Okay, so this one we already calculated just now. Total distance kita adalah sama dengan 115 meter. And total time adalah sama dengan 50 second. That's the whole journey of the lift. So you will get, it is equal to 2.5 meter per second. And then for average velocity, total displacement tadi adalah sama dengan 15 divided by 50 seconds. So you will get 0.3 meter per second. Okay, so now the last one, sketch the acceleration against time graph. So how do we sketch the acceleration time graph? Okay, so this one nampak susah tapi sebenarnya senang sahaja. Okay, so which question is it? Question C, question E. So question E, first of all, okay, tulis lukis paksi X and Y, di mana dia minta adalah tadi acceleration, right, which is AT. So label here the acceleration, meter per second squared, and then the time, which is in second, and then just label the number ikut time yang dekat dalam original graph. So we have 0, 5 until 50. So label that one first. Five, 10, 15, 20, 25, 30, 35, 40, 45 and 50. Okay, so kita akan tengok acceleration in each time interval, which actually kita sudah kirakan tadi. So first acceleration kita, which is mana sudah tadi tu, A1. A1 is 0.4, A2 is 0.2, and then here A4 0.8, negative, this one 0.4 meter per second squared. Okay, so daripada saat 0 sampai 5, okay, 0 sampai 5, the acceleration is 0.4 meter per second. So agak-agak dekat sini lah, 0.4 meter per second, sini 0.2. So first from here to here, which is daripada 0 ke 5 adalah 0.4 constant. And then kamu akan buat dotted line. Okay, make sure you use your own ruler. I don't have ruler here. Okay, next one we have daripada 5 saat kepada 15 saat, we have acceleration 0.2 meter per second squared. So from here to 15 second, 0.2. So daripada sini ke 15 second. Okay, something like that. Wait, let me lukis dahulu. Okay, like this. And then next one is, okay, from 15 to 20 second, acceleration 0. 15 to 20, acceleration 0 maksudnya dekat sini lah kamu akan lukis. And then next one, okay, I'm not gonna refer to the notes. Okay, kamu refer balik . So next one, 20 to 25, acceleration adalah negative negative 0.8. So negative 0.8, which means here to here. Is it? Okay. Let me make it nice. And then mesti dotted line, this one. Okay, next one. From 25 to 30 second, acceleration kosong balik. So just straight line on the x-axis. And then from 30 to 35. Okay, 30 to 35. Acceleration balik kepada negative 0.8. And then from 35 to 40, acceleration balik lagi kepada kosong. So ngam-ngam dekat paksi X ni. And then from 40 to 50, acceleration 40 to 50 acceleration adalah sama dengan negative 0.4. She's around here. Okay, so you use your own ruler so that nampaklah dia nampak nice sikit lah. Okay, don't follow me. I just do it roughly. So this is how you sketch a acceleration against time graph. Okay, you just follow the time interval, exactly the same time interval, but now the acceleration is the y-axis is the value for the acceleration that you have already calculated in the first question. Okay, so that's all for example 4. Thank you.